Alright, the first one, you should have them. If you don't have the homework in front of you and you want to follow along on this, then I'm reading it off. It is y equals 3 sine of the quantity of x plus pi over 4, close the quantity, minus 2. Alright, so I can go on the inside of this and try to build this. So I need function. I have to double tap first. Here it comes. I think it has to reload every time we go to a new page. Okay, now we can try it. Function sine of x. And I'll have to mess with my x and y axes on here, at least for this first time. I think we need to take this up to 6. That should be negative 6. And then 6. And then the x-axis. I think your graph paper went from what? Negative 90 up to what? 450? And then it went by 90 degrees, and we have to be in degrees. Okay. So there's the sine of x. Now the first thing you had to do for problem 1 was stretch it, and you have to do that with the 3. So right here I'm going to build the new graph, and I'm going to put 3 sine of x. See what happened to it? X-intercept stayed the same. I'm afraid to get the pointer out because it might freeze this up, so I'm just going to have to talk through it. It stretches it up to 3 and then down to 3. And I'll close this in a little bit so you can see it a little better. Alright, the next thing you can do is you can add the plus pi over 4. Pi over 4 is the same thing as 45. So in off blue, we're going to do this. We're going to add on to it 3 sine, and then we're going to have x plus 45. Now see what's happened there? It shifted at 45 degrees to the left. Oh, that's green, not off blue. And then the last thing we can do is we can put in the minus 1. So I'll go back and do 3, and then sine of x plus 45, close that off, and then put minus 1. Oh no, minus 2. So there's your final graph. And here are some points that you might want to take note of. I'll just tap the graph and get rid of that. That's an x-intercept, 93.2. Now I don't expect you to hit that down to the 10th of a degree, but if you're in that vicinity, then you're doing good. If you're crossing just a hair to the right of the 90, you're doing good. If you've gone down to negative 5, if your maximum or your minimum is at negative 5 there, and your maximum is at 1, you're on the right track. This graph crosses somewhere near 0 there. And let's see, what's that x-intercept here? Looks like about a 360. The second homework problem is y equals negative 2 sine of the quantity of 2 times the quantity x minus pi over 12, close both quantities, and then add 1. Okay, so we'll start here with the basic thing, and that's going to be sine of x. That is sine of x. Now, the first thing we can do is put negative 2.
At this time, I need...
Alright, so the next thing we're going to do is negative 2. We're going to put the negative 2 in front. So here's negative 2, and then sine of x. See what's happened? It has stretched it down and then flipped it. So a max is now a min, and a min is now a max. And you've gone to positive 2 and negative 2. Okay, so the next thing we can do is we can put in a 2 in front of the x. If we look at this, negative 2 and then sine of 2x. Look what happens there. It crunches it in. And we have divided the crucial points in here by 2. And the red one is where we're at on the latest movement that we've done. And then if we do -2 sine of 2 times the quantity of x, and then pi over 12 is the same as 15 degrees. So plus 15. Here's where we end up. And it's in the blue. We'll zoom in on that. It's moved at 15 degrees to the left. So look at the red, look at a maximum point on the red, and then look at the blue. And it's moved at 15 degrees to the left. And we'll stay with the blue, and I'll just do +1 on the end. So it's moved everything up 1. Number 3, if you're following along, it is sine of the quantity of 3 times the quantity x plus pi over 3. Close the quantities and then -1. Alright, so we'll start with sine of x. There's sine of x. That one's in green. Okay, let's look at sine of 3x. We'll start with sine 3x. So it's scrunched it together. And then we can stick with that one. Now let's do a new one. We have to put in the plus pi over 3. Pi over 3 is 60 degrees. So I'm going to go with sine, and then we'll have a 3 times the quantity of x plus 60 degrees. 60 degrees. There we go. There it is. And it's moved at 60 degrees to the left. And then if we stay with that one and just put in a -1, it's bumped it down. 1 for everything. Next one is 3 sine of the quantity of 3 times the quantity of x plus pi over 3. Close the quantities and then +2. So we'll start with sine of x. Oh, and I have to redo my settings again. Now this is wonderful. Go to degrees, y-axis will go from -6 up to 6, and then for the x-axis we'll go from -90 to 450. Let's just make it 540, and we'll step by 90 degrees. Alright, here are your important points there, and we have intercepts there. And I'll try to close this in together a little bit. Those are all the points you're supposed to know for the graph of sine. Okay, so we'll take those out one at a time, and then we'll go in and start doing the problem. Here's what happens if you put 3 sine of x. And we'll just pick out a couple of these. There's a point. There's a point. So it stretches it up 3 and also down 3 to that point. That's the amplitude. The amplitude would be 3 on this one. Okay, so let's add some more onto it. Let's take these points out, and then we will go to the inside and do this. So now we have 3 sine of 3x. Look what's happened here. We had 90, and now we have 30. So it's divided the degrees by 3. Okay, we'll take that out and we'll start adding on to it. We'll have 3 and then sine of 3 and then times the quantity of x plus 60 degrees. Okay, so this is where we're at now. Our last movement was at green. There, and let's see where we're at here in purple. From 30 degrees to -30, so that accounts for the plus 60 degrees. It moves at 60 degrees to the left. And then if we do the +2 on it, still stays at -30 degrees, but it goes up to 5. And that's the final graph. For the last one, I'll just take these out and put the entire last one in there. And you can watch as it's built, because it shows it and moves it as I'm typing it in. So we start out with negative sine of 3, and then times the quantity x plus pi over 2, which is 90. Close those quantities off, and then you'll have plus 3. So this is day 2 of lesson 11. We'll stick with 2 days on this, transforming the graph of the sine function. We're going to do this one. Negative sine of the quantity of 2 times the quantity x minus 45. Close the quantities and minus 2. Okay, so the function we just looked at. What is the first thing that we should do? Sine function. All right, let's do the sine function. So this one will be sine of x. And in case you're in doubt, I'll highlight the points here for you. You should plot these points on your graph. And I'll shorten this up a little bit, try to get them all on there. So we have the sine function on here. What is the next thing we have to do towards graphing the entire thing? What's our next step? Alright, so it's negative sine, so what we want to do now is to look at this. We're going to put in negative sine. And this is what happens. So the blue line is what we just did. So I'll take out these points in red so it doesn't get too confusing. And here are the new points when we flip this. Whenever you do a negative sign, it's just going to make your maximum points minimums and vice versa, but the x-intercepts will stay the same. I've taken out the red sine equation, the basic one, the parent function. So now we've done the flip. What should I do on the inside next, inside of the quantity? The 2x is the next thing that we were doing in order, so that would have to be now a negative sine of 2x. So there's the green. That's what's happened, and I'll take out these blue dots, and I'll just put a couple on here. Here's the green, or the blue. There's a blue one. And there is a green one. And I'll zoom in on this. So what we do when we have a constant up against the x on the inside is we divide our critical points by that constant, which would be 2 in this case. So 90 divided by 2 is 45. And we'll take a look at this. That's 180. And it's moved over to 90. And I'll zoom out so we can see some more of these. Let's see. Here's a blue one. And half of that, half of the 360 is 180. Here's a blue one. 270. 135. So I'll take out these blue points. And we'll just stick with green. Okay, so there's a point, x-intercept, minimum, x-intercept, maximum. There, whoops, that's a blue point. There's a minimum. And I think we still have a little more to go on your graph paper.
So, Mr. Skinner,
yeah.
why does that graph narrow out?
The question was, why does it narrow out and like bunch together? And the reason is that constant of 2 up against the x. It's going to double how many waves we have coming through. Remember before with the basic sine function, the distance between the maximums was 360. So since we've divided by 2, the distance now is going to be 180. So look at those maximum points where you have 135 and 315. The difference is 180. Now what's the next move that we have to do now that we've arrived at the most recent step? We've done the negative sign on the sine, and then we've done a multiplication of 2 on the x. What's the next thing we have to do? Minus 45. In what direction will it shift that graph? To the right, 45 degrees. Okay, so we have negative sine of 2. Now it's times the quantity of x minus 45. And look what happens. I'll zoom it in a little bit for you so you can at least see the pattern a little bit largely. This is where we left off on the green. We had a maximum at negative 45. And when we subtracted 45 in the middle there of our quantity, it's moved it 45 degrees to the right. It does the opposite of what the sign says. This one was at positive 45, so now we're at 90. This one was at 135, so now it's at 180. Here are the x-intercepts. This one is 0, so now this one's at 45. This one was at 90, so this one is at 135. I'll take out the green points, and I'll just leave in the purple. So you can see a pattern and start to there we go. I thought I lost my graph there for a second. There's a pattern. You should be able to finish it off to the right with that. Alright, so let's take out, well, let's leave those points in there, and we're going to do the minus 2. So we'll do minus sine, actually negative sine, and then 2 times the quantity of x minus 45, and then we'll do the minus 2 at the end.
This is the final graph, right?
And this is the final graph. So it's separate from the rest of it. It's bumped everything down 2. So I'll go ahead and put the points on the orange. And that's the final graph. Bumps every point on there down 2. There's the midline. I'll attempt to draw on this. The midline is y equals negative 2. And the amplitude is the distance from here down to that midline. So it's just 2. It's the absolute value of A. Or actually it's 1. The amplitude is 1, and the midline is y equals negative 2. Here's the homework. You have 5 of them to graph, so you're going to need 5 sheets of graph paper.